Hi, welcome to Math as a Language. Today's topic is perhaps one of the most challenging of all that we will encounter. Not all, but one of the most challenging ones that most students encounter in algebra as we try to make the transition from basic math to algebra. And that is, how do we go about developing and how do we develop and use a problem solving plan? So we're going to take a look at problem solving today, after all said and done. Problem solving. Okay. Problem solving. All right. Now, we've said this often, and we say it again. Very rarely, if ever, and that you run across an expression like this as you go through your daily activities: 2x plus 5, or whether it's a 3m minus 7, or just simply a 2z. These are algebraic expressions, and these expressions, to be quite frank with you, aren't just floating around there as you go through your activities at the mall or shopping, or they're just not there. They exist in algebra textbooks, and generally for one of two purposes: more often than not, for you to practice your skills, or they're created as a result of an expression or a problem that the teacher or someone wants you to solve. Okay, and it's that second aspect that we're going to take a look at today. Now, one of the hardest, the most difficult parts of algebra for many students is creating these expressions when you're given a problem, or in terms of a problem in a word format, if you will. Okay, so we're going to go ahead and practice and take a look at this today. And even this, we must admit, is an artificial example, but that notwithstanding, we do have to practice these skills, and so we're going to go ahead and do that at this time. All right, so here we're going to have the situation. You had this you and these two young people had a business over the summer. They made money from mowing lawns, perhaps, and all we know at the end is that John made $50 more than twice what Mike made. All right, so we have that statement, and we also know that Mike made let's say that Mike made $73 from his business. Okay, so Mike made $73, and the question we'd like to know is, how much did Okay, so how much did John make? All right, so here's our problem that we're going to solve. John made $50 more than twice what Mike made. Mike made $73. So how much did John make? All right. Now, the obvious thing here is that if you have this entire problem presented to you as a complete package as it is here, clearly you have a few choices about how to find out how much John made. Okay, but the reason why we've put it this way, we wrote it this way, and we wrote it in different colors, is to recognize that when you have a problem solving situation in life, in real life, sometimes a few things may happen, not the least of which is that all of the information may be available to you, or another possibility that, well, let's go ahead and list them. All of this information may not be available to you. The question is, do you have all of this information? Do you have all of this information? Abbreviate here, all info. Okay, and if you do not have all the information, if not, what can you still do? If not, what can you do? What can you still do? Okay, because very often when you're solving a problem, whether at work or in life, generally you want to continue. Sometimes it's not just a matter of like in homework, you just sit down and do the problem all at once. Sometimes the information, you have to go through an information gathering process, and sometimes you just don't have all of the information. Okay, all right, let's take a look at what we do have here. The part of the statement that is written in blue here, okay, that information lends itself very nicely to an algebraic expression. That is to say that this information that's in blue here, this information, we can go ahead and translate that information into an algebraic expression independent of the other two statements. All right, and we're going to go ahead and do that now at this point in time. We'll use J for John. Made is equal to $50 more than, and this is where your basic math skills come into play, and just your knowledge of mathematics. We know that more than is an increase. Okay, so we're going to add $50 onto something, and that something is whatever Mike made. All right, and so we're going to use M for Mike. All right, so J is for John, M is for Mike, and very often when you're solving a problem algebraically, you would identify these variables. So we'll go ahead and do that on the side here. So we're going to have J for John, and we're going to use M for Mike. So we would identify those variables. Okay, so we have J and M. Okay. However, what we do know is that we want to relate those two variables, and J is 50 more than twice Mike. We forgot our twice. In fact, that's an important aspect. Now, here's an important thing too. We translated this equation, but as we just indicated, we forgot a key element here, and that key element was the twice. Okay, so and then every opportunity is a learning situation, or a learning possibility. So the key here is that this twice was important, and we missed it. Okay, and obviously, if we had gone ahead with this equation or this translation, there is no way we would have gotten the correct answer, but clearly too, we want to recognize that we would not have been terribly wrong. And there's a difference that we need to recognize in algebra between the concept. Okay, so we talked about algebra being conceptual, okay, being able to make those translations, and between the difference between the concept and computation. And computation is just being able to add, subtract, multiply, and divide, and that is to say, doing the mathematics after we've translated the problem, so translated the words into symbols. Okay, so conceptually we had made an error, so we're going to go ahead and fix that here at this point in time. We know that this should have been twice. So we needed a 2 here, so we would have had an error in the concept, but we fixed it and found it, and we've corrected it. Okay, so let's go ahead and rewrite this one more time. So we're going to have John is $50 more than twice Mike. So this would be our algebraic equivalence, or the relationship between John and Mike. Okay, all right, so we have that now. So that now just came from this first statement. Now, the second element here in red, this part, Mike made $73. And sometimes in life, it is this key element, or a part to solving the problem, or whatever the encounter is, that you're missing. Because you have to have all of the information, and sometimes you just don't have enough information. This first statement by itself is not enough information to answer the final question. This key element here, knowing what Mike made, is an important part. So we're going to go ahead and use that now, because now we know that Mike made $73. Okay, so Mike made $73, and knowing that what M is, we can now go ahead and solve the problem, because it was a key facet in terms of answering this final question that we're looking for, which is how much did John make. And we now know that knowing Mike's salary and knowing this expression, putting these two things together, these two pieces of information together, will allow us to say that John made twice 2 times this 73. That 73 goes here, because that's what Mike's made during the summer in the business, plus the $50 more, because John made $50 more than twice what Mike made. Right. And now, as we said, this computation, just go ahead and finishing off the computation, doing the mathematics, if you will, that has to do with this, the basic math that goes with it, we would have 2 times 73, which is our 146, plus 50, plus the 50, and our final answer, we can now say that John made what? $196 in his lawn mowing business over the course of the summer. And so that would be our answer as far as what John made in the business during the summer. Okay. Now, the obvious question that many of you may be asking is this: well, couldn't we just have done that based on without the algebra? And to be quite frank with you, the short answer is yes. This algebraic approach was not mandatory, it's not absolutely necessary, okay? But because there's going to be many instances, and this is where we talked about mathematics being all around us, and intuitively, with or without algebra, many of us would be able to very easily, clearly, to solve this problem. But the question that we want to recognize is that taking an algebraic approach and learning the algebraic approach, this is to be frank with you, it's just practice. Okay, if the concepts are clear and we can translate them easily, then clearly it may not be necessary to go through this algebraic method, if you will, because it is not absolutely necessary. But the question, what we want you to recognize, and in math we recognize, it's that these relationships, and this is the key one here. Coming up with this relationship is the key component in terms of solving many of life's problems, if you will. Okay, and in these equations, that's where the scientist and your mathematician or your engineer spends a lot of time observing, coming up with this equation before we can and finding the key, perhaps missing ingredient or missing part, and putting these all together in terms of becoming very good problem solvers. Okay, so but the only thing we would like to end here is knowing what the elements are, that these elements all may not exist at the same time. Sometimes you may be able to come up with a relationship but not know a key feature that's necessary to solving the question, or coming up with what's the proper question that relates these two elements. That's also an important thing to recognize here. But after all said and done, and we'll stop at this point, recognize clearly that problem solving in mathematics, problem solving in life, even though it may look like a single question, okay, there are always key elements, and those elements can be broken down into parts. First, establishing a relationship, finding that key component, and knowing what question to ask, and clearly what question that must be answered in order to get the solution to the problem. And those elements exist in mathematics. We practice it in algebra, and we practice it in life. Well, I think that's quite enough for today, for this lesson, for this topic. We'll pick up and look at this topic again in the future. But we thank you very much for visiting us at this point in time, and we look forward to seeing you in the next video. Take care.